Hello, this is Mr. Huber. In this video, I'm going to record an answer key for the recent quiz regarding reference angles and triangles and trig in the coordinate plane. So I'm going to go through these. These might not be in the same order you saw them because it randomizes the order, but these are the same questions you would have seen at some point through your quiz. Okay, so I'll go through these. I'm just going to go relatively quickly, but you can always pause, rewind, and do different things if you need to slow it down to understand any of them particularly more. So the first question is, given theta equals 612 degrees, alpha, which is the reference angle, equals what? So when we have an angle more than 360, the first thing that might make sense is just to subtract 360 from it. If I subtract 360 from this, I get 252. So this is the same as a 252 degree angle. If I'm going to draw a little sketch over here, when I go 360 degrees, I've gone all the way around. Then I go another 252 degrees, and I'd have my angle out there. That's 612 degrees total for theta. I go 360, and then I'll kind of do it in red here. Then that's the other 252. And the reference angle is this angle in here, always back to the x-axis. That's our reference angle. So we subtract 180 from this. Okay, 252 minus 180, and, excuse me, we'd have 72 degrees. Okay, so our reference angle is 72 degrees. Next question, given a reference angle of 27 degrees in quadrant 2, so we're going to draw out a reference angle in quadrant 2. Okay, got our reference angle right here. 27 degrees is our reference angle. We want to know what theta is. Theta would be this angle right here, that's theta. So that's 180 minus 27. 180 degrees would be going all the way around to here, right? Back to the x-axis, that would be 180 degrees. So we want to take 27 away, and we'll have left for what theta is. So 180 minus 27 will give us the, let's write in red, the theta of 153 degrees. Okay, that's your answer there. Given the theta of negative 115 degrees. Okay, so a negative angle measure, we start on the positive x-axis and we go clockwise, 115 degrees. So this is theta negative 115 degrees. Remember, your reference angle is always to the x-axis. It's always positive, always acute, and always drawn to the x-axis. So this will be 180 minus 115. So we have 65 degree reference angle. The fourth question was a reference triangle always, and it's always be drawn perpendicular to the x-axis. If I take the last couple of diagrams I had, if I want to draw a reference triangle, I would draw a reference triangle back here to the x-axis. In number 2, a reference triangle, I would draw it perpendicular to the x-axis. So the reference triangle will always be drawn perpendicular to the x-axis. Okay? Number 5 here in a 30, 60, 90 special right triangle. So I'm going to draw a 30, 60, 90 reference special right triangle here. So we have 30, 60, 90 triangle. It's 30 degrees. Okay. The longer leg is equal to 1/2. So the longer leg here is across from the 60 degree angle. We want to find the shorter leg. So that's the longer leg divided by the square root of 3. Okay. So this would be 1/2 square root of 3. That would be, all right, let me back that up. I'm going to write next to it. So I'm going to need to multiply by root 3 over root 3. That's square root of 3 over 6. Square root of 3 times square root of 3 is 3 times 2. So square root of 3 over 6. You've got to rationalize the denominator there. Square root of 3 over 6. Okay, then number 6 was for ratios of trigonometric functions in the coordinate plane. Why is r always a positive value? It's the radius of a circle with center at the origin. So if I take my coordinate plane, okay, and I draw a circle around this, the center at the origin, okay, the radius, okay, here, that's r. Doesn't matter if I draw it out this way, that's r. I draw it down here, that's r. It's a radius of a circle, so it's always positive. It's the radius of a circle with the center at the origin. All right. Number 7, why is cosine negative in the third quadrant? So cosine, the couple things that were key here was cosine is x over r. Something about it being the ratio of x over r, x divided by r. Okay. In quadrant 3, okay, x is negative. We just talked about r is always positive. So cosine is equal to a negative over a positive. Negative x over a positive y in the quadrant 3, which means there will always be a negative ratio. So the keys were x is always negative in the third quadrant, r is always positive, and cosine then is the ratio of x over r, which will give you a negative. Some people had things like x is always negative, so cosine's negative, but that didn't relate to why x being negative would mean cosine's negative, right? That means it's divided by r, which is a positive, right, about the ratio, and the x being negative and the r being positive. And so I went through and graded those manually. Those were the key things I was looking for to get you the full points on that. All right, number 8 here, it says given tangent is greater than 0 and cosine is less than 0. So going back to what we talked about in that last problem, right? Where is cosine positive or negative? Where is tangent, sine? Where are these positive or negative? So tangent is positive in quadrant 1 and in quadrant 3 because tangent is y over x. So for that to be positive, we need both numbers to be positive, quadrant 1, or both to be negative. A negative over a negative will still give me a positive ratio. Okay, so that would be in quadrant 3. Cosine, okay, is negative in, cosine is x over r, as we just talked about. So it's negative in quadrant 2, where x is negative, and in quadrant 3, where x is negative. So in what quadrants does the angle lie where it is both tangent greater than 0 and cosine less than 0? So quadrant 3 would be the answer, where cosine is negative and tangent is positive. That's the only quadrant where both those things are true. All right, moving to number 9. Given an angle in standard position that terminates through the point 8, negative 6. So I'm going to draw a quick sketch of that. Okay, that's going to be in the 4th quadrant. Okay, this point right here, 8, negative 6. Okay, so we want to write the ratio for sine, which is y over r, and tangent, which is y over x. So to write the sine ratio, we need an r. We have an x and a y. We have x and we have y. So we could actually write the tangent ratio right now. That's fine. Y is negative 6 over 8. That would be negative 3/4. Okay, sine y over r. So in order to find that, we're going to need to find an r value. So r squared equals 8 squared plus negative 6 squared. R is equal to 10 if you go through and solve that Pythagorean theorem there, or you might recognize as a 3, 4, 5 all doubled, so that's the 5 doubled, which is 10. So R is 10, so we're going to have sine is y over r, or negative 3/5 reduced. Okay, now we're going to go to the last couple problems here. So number 10, okay, tangent is 12 over 5 in quadrant 3. Tangent 12 over 5 in quadrant 3. So that was a little sloppy there. Let's try that again. Okay, so quadrant 3, okay, 12 over 5. So tangent is y over x. So in quadrant 3, that's going to be a negative y over a negative x. So negative 12 over negative 5. Okay, we don't have to draw it really to scale or anything, just recognize we got there. This is the point, negative 5, negative 12. That's a y over x. So tangent y over x, 12 over 5 would be negative 12 and negative 5. All right, we want to write a ratio for cosine. Cosine is x over r. So again, we have the x value. What we need is the r value. So we need r. Okay? So we're going to have r squared equals 5 squared plus 12 squared. You can put the negatives in there. It's not even really that important. R is going to be 13. Because when you square negative 5 and negative 12, they're still going to come out positive. So it'll be 169, square root them. r equals 13. Okay, so for my cosine ratio, x, negative 5 over r 13. Negative 5 over 13 for cosine in quadrant 3. All right, and then for the last problem here, number 11, it says theta terminates in quadrant 2. Okay, so if we just want to get an idea where it'll be, right? Quadrant 2. Okay, tangent is negative 10 over 5. Again, that's y over x. Okay, and if it's a negative, all right, that means in this case the x value is negative in quadrant 2. And on the school address it was negative and then 10 over 5. The negative sign was in front of the whole fraction, not making it look like it was a negative 10. Okay, it's a negative fraction, which means either number could be negative. In this case, the number that would be negative would be the 5. So we'd have negative 5 comma 10. Okay, we want the cosine ratio. So cosine is x over r. So if I draw that in, my r value, I could find, okay, r squared equals 5 squared plus 10 squared. R squared equals 125. And when you square root both sides, r is going to be the square root of 125, which is 5 square root of 5. Simplify, right? This is 25 times 5. Square root of 25 is 5. So r is 5 root 5. So x is negative 5. R is 5 square root of 5, which is negative 1 over the square root of 5. Those would cancel out. Reduce the fraction. Now I need to rationalize the denominator. So I need to multiply by square root of 5, square root of 5. That's negative square root of 5. Over 5. Right? So a little bit of work there in terms of working with the radicals, simplifying, rationalizing, and some things there. So knowing the sine, cosine, and tangent ratios in terms of x, y, and r values, how those relate to the coordinate plane, going back to the reference angle questions at the beginning, and knowing that reference angles and reference triangles always go back to the x-axis, and how we can work with those measures as well. So hopefully that helped. If you needed to go back and look through any of the rest of that, slow anything down, watch it again. If there's any questions you still have about work and answers you're not quite clear on, make sure you're clarifying them with me. Contact me or ask about them when we have class meetings and Zoom sessions or whatever it might be, so you can make sure that you're understanding anything you had trouble with as we continue to go forward with this.